right, and here we go with part 2 of the final exam review in fall semester 2023. And with the posterity out of the way, let's dive in. Okay, what do we have going on? We would like to solve a triangle given here. We're given 2 angles and 1 side. But we know that anytime we start with 2 given angles, we'll be able to use the law of sines to solve this triangle. Because we'll really know all 3 angles right away, since the third angle in a triangle has to add up to 180 degrees. Of A is equal to 180. That's an awkward looking 8. 180 minus the other 2 angles. So minus 34 degrees. Minus 34 degrees minus 63 degrees. And if we do that math, hopefully we get 83 as our result. So down in the box, I'll put A equals 80 degrees. So now I know everything about letter A, which means I can use the law of sines. I can set B or C equal to the A ratio and get an answer from there. So I'll do that. B divided by the sine of B, which is 34 degrees. Is equal to everything I know about A. 3.2 divided by, let's try to keep that in the same level, divided by the sine of 83 degrees. And solve this thing for B, which means I should multiply sine of 34 degrees over. So B is 3.2. Well, 3.2 times the sine of 34 degrees divided by the sine of 83 degrees. And again, go to a calculator to get that number. I got 1.80. And that'll be inches. Since our first length was given in inches, all of our lengths should be given in inches. So I'll drop that in the box as well. B is 1.80 inches. And then I've got to go solve for C. But the trick I'm going to use here, if I just copy and paste the work that I did for B, and then simply replace all of letter B with all of letter C, I'll get my C answer. So instead of B, I want C, and instead of angle B, I want angle C. So I'll just hot swap those couple of pieces. And now I have an equation that solves for C. And when I went to a calculator, I got 2.87. Again in inches. Question in chat. Oh, that's a longer question in chat. What do we have? Also go over the example. It states use the smaller and larger angle. Yeah, the 2 angle stuff. Yeah, I'm pretty sure that we've got a question like that on here. And if we don't, it must be because I thought it wasn't that important for the final. But I'm pretty sure there's one coming up. And if it's not here, but you do want to see it, there should be a similar example in the exam 4 review. At least something in exam 4. And yes, it is the 2 triangle solution thing. Yeah, that's the one we are talking about. If I don't get to it in this review, you can check the exam 4 review for a similar problem. But I think we'll get to it in a minute. Excuse me. I'm dying. Ooh. All right, we're fine. Part B said find the area of this triangle. So we'll go to one of our area formulas. I'll use the one that is 1/2 AB sine C. And then I just have to plug in values for each of those things. 1/2 times a number times another number times the sine of yet another number. I chose to use a 63-degree angle because I was going to go with angle C. So then 1.8 for B and 3.2 for A. So it's just important that in this area formula, I'll use each letter once. All 3 letters are important for figuring out the area. And I put that in a calculator. I got 2.57. And now our units are square inches because we're measuring an area, which is a 2-dimensional value, instead of a length, which is just a 1-dimensional value. Will we get a formula sheet on the final exam? Not exactly. I won't be giving you a formula sheet on the final exam, but the final exam is open note. So which I think that probably answers the question. So I'll leave it there. Then the other one, does the square root of s times s minus a c also work for the area on these? Just double checking. Yes, it does. Though I think that particular formula is a little on the unwieldy side because it just has it has more stuff to calculate than the other ones. So I don't use it that often. The only time I bother going for that semi-perimeter version of the area calculation is if I'm given all 3 sides at the outset of the problem. Like if the given information is all 3 sides, then I can go to that without having to find any of my angles. Which also means that if I made a mistake when calculating the angles, it wouldn't put me in double jeopardy. Wouldn't get penalized twice if I used the other formula. But yeah, as long as I already know some of my angles, I'll use the easier calculation. All right, then up next, what have we got? Read the equation of a graph. Oh yeah. All right, so let's do this thing. I just look over the whole problem real quick. Okay. With the added little caveat here, both the x and the y scale are 1? Is 1? The x scale is 1 and the y scale is 1. There we go. Then I don't have to worry about grammar. So every grid mark is a 1 by 1. So what do we want to do first? So notice that we're going to be looking for a sine graph. Though that won't be important until a little later on, not until we pick our phase shift. So for now, let's just come up with other things on the graph. I usually like to start with the range. So the range is going to be, I can look at these 2 pieces right here. I have a minimum at -2. I have a maximum at 8. So my range is -2 to 8. I can use the range to find both my amplitude and my vertical shift. So my amplitude should be half the length of the range. The range has a length of 10, half of that is 5. And the vertical shift, which isn't even listed there, it's not until D. The vertical shift is just going to be the midpoint of that graph, or the midpoint of the range. Right in between -2 and 8 is 3, which is a totally acceptable way to get those 2 answers if you can see your way there. The downside is that there's not a lot of work to show there. So if you were interested in showing some work, or maybe you don't see exactly how I just pulled those 2 numbers out of a hat, then here's a more formulaic version of that work. The amplitude should be the difference between the range values, so the maximum minus the minimum, 8 minus -2 over 2. Then that makes 10 over 2, which is 5. I'm going to use my copy and paste trick again. Because the formula for the vertical shift is pretty similar. So if I change amplitude to vertical shift, I just want to be adding those numbers instead of subtracting them. The vertical shift is the average of the two values in the range. So 8 minus 2 is 6, and then 6 over 2 is 3. And that's where I came up with 5 and 3 for my amplitude and my vertical shift. So I think it'll be helpful if I draw that line in. So that's what I'm going to do. And by that line, I mean my vertical shift line. Be specific, because it's my job. All right. There's our line. It's y equals 3. And that gets me to my vertical shift. Once I've got that on there and knowing I've got to get a sine graph, I might as well pick my phase shift right now. I'm going to go with this point right there for the vertical shift, that one in green, or for the phase shift, excuse me, which is at a value of -3. There are several options that I could have picked for my phase shift. Any of these other points that I just marked in magenta also will work for the phase shift, but I'm going to do the work for the one that I picked in green. The reason I chose the one in green is it is relatively close to the y-axis. I usually pick one close to the y-axis. And also it's going to make a positive a value right there. Generally think picking the positive a value is nice because I just don't have to worry about an extra negative sign. Slightly, ever so very slightly less work if I choose that green point. So that's why I went there. And lastly, we got to get the period. So the period is just the distance between any two like points in a cycle. Usually we do that by calculating the distance between two maximums, or the distance between two minimums. I said the distance between two minimums. Either one of those will work, or we could even get a distance along the center line. Just if we go along the center line, we have to skip over a point in the middle. Because you can see if we just connected 2 points along the center, we'd only get half the period. Pretty easy to see that stacked up next to either of the other two lines drawn in for period. So if we go through the middle, we need to capture both a peak and a valley, which means we have to skip over 1 point in the middle. But if we're doing maximums or minimums, then it's just easy, peak to peak or valley to valley. In either of these cases, let's just count up the number of boxes. 1, 2, 3, 4, 5, 6, 7, 8. Or 8 times 1. Each box has a length of 1, and there are 8 boxes, so my period has a length of 8. All right. Then with that done, we should go get the rest of these things. We've got our amplitude and our vertical shift, which means that we know our D value is 3, because D just is the vertical shift. A is plus or minus 5, right? So whatever the amplitude is, it's either the positive that or the negative that. And because of the particular phase shift I picked, it's going to be positive 5. So I picked a spot where the graph starts going up, starts in the middle and goes up, instead of starting in the middle and goes down. So a positive 5 for A. Right, and that just leaves B and C, which both require just a little bit more calculation. So B is always 2 pi over the period And our period is 8. Said our period is 8. There we go. That'll simplify to pi over 4. And finally, we got to get our phase shift. Or no, we already have our phase shift. We have to get C. So C should be B multiplied by the phase shift. Which means this thing is pi over 4 times -3. Looking very Christmassy down there. And then 3 or -3 times pi over 4 is -3 pi over 4. So the last step is to just put all this together. I have A, B, C, and D. Now I just have to put it into an equation. So f of x should be 5 sine of pi over 4x minus c. So this is going to be a minus -3 pi over 4, which will become plus 3 pi over 4. So just remember that c and the number that shows up inside the equation always will have opposite signs because it's bx minus c. So it's plus 3 pi over 4, not minus 3 pi over 4. And the last step is plus 3, plus our vertical. And that's our equation. Yeah. What else have we got going on? Oh yeah. Next up, I think is gonna be everyone's favorite problem. Verify the following trig identity. Work going down, work one side only. Yeah, let's solve this thing. So anytime we're trying to solve one of these identities, I always say that we should start by working on the more complex side, because a simplification process is a lot easier than a complication process. So simplifying is the thing we want to do. I think the right side looks more complicated, so I'm going to start there. And I'll try to get it equal to tangent over cosecant. So step number 1. Any angles that are not simply x or simply theta, depending on which variable I'm using, I want to change those so that they are in that form. So I've got cosecant of pi over 2 minus x. That's a cofunction identity, and the cofunction of cosecant is cosecant, or just secant. Nobody calls it cosecant, except for me, and I'm probably wrong. So don't do that. Minus cosine of -x. Cosine is an even function, so cosine of -x is just equal to cosine of x. That negative input will not change anything. So now we've got to add these. We've got to figure out what to do from here. So probably I'm going to change to sines and cosines because I don't see any other good step right now. So secant is 1 over cosine x minus, still have cosine x over here. And now with everything in terms of sine and cosine, I'm going to get a common denominator. Since I've got 2 fractions now that I'm trying to add together, or at least 1 fraction that I'm trying to add. So I'll multiply by cosine x over cosine x, which will be 1 over cosine of x minus cosine squared over cosine x. And then those 2 fractions now have the same denominator, so I can combine them. This is 1 minus cosine squared over cosine x. Come on. There it is. Okay. Well, nope. Cosine x. There we are. Getting ahead of myself. All right, and it looks like I've got a Pythagorean identity up top, so I might as well use that now. 1 minus cosine squared is sine squared. Divided by cosine of x. And that's like pretty simple right now. Don't have a ton more steps to take here that immediately jump out. So I'm going to go remind myself what function or what value I'm after. So scrolling back up to the top, I want to show that this thing is equal to tangent of x over cosecant of x. I'm just going to write that in. Tangent x over cosecant x. And I want to show that this thing looks like that. So tangent is sine over cosine. So in an effort to make this thing look like the left side of the equation, I'm going to separate it out into a sine over cosine times whatever else is left. At least get my tangent going. So sine of x over cosine x times the bits that'll be left over. I only used one of my sines in the numerator, so I'll still have another sine x over 1. And then I can convert those things around. Sine over cosine is tangent x. And sine of x over 1 is the same as 1 over cosecant of x. And at that point, I'm done. Let's tangent over cosecant. So last couple steps were a little odd, but I just needed to go look at the thing I was trying to become equal to and go from there. I think the problem on the final won't be as difficult as this one. I think. All right. Up next, problem 13. More stuff with polar coordinates. I would also look over this one before quiz 8. I think that would be a good idea. Quiz 8. Probably a good idea to just review this problem before that quiz tomorrow. Or if you're watching this the night before the final, the quiz that was like 4 days ago. But I digress. Back to what we're doing right now. Plot and label the following polar coordinates and convert it into rectangular coordinates. That's our jam. So my polar point is 5, -2 pi over 3. I want to plot that and convert it to rectangular coordinates. So first things first, though. I've got this -2 pi over 3 angle, which I could go with. If I want to just plot where -2 pi over 3 is, that's fine. Or I could start by getting a coterminal angle there. Coterminal to -2 pi over 3 is 4 pi over 3. So either way is going to be fine. So 4 pi over 3 is the angle that I care about, or -2 pi over 3. That should show up right about where? Should be this line here. Hey, it even was to scale. I love that for me. Cool. that my phone going off? No, it's not. Is it? No. Okay, so this is the line y, or nope. This is the line theta equals 4 pi over 3. Notice it's the same line as theta equals pi over 3. But to get the point that I want to go to, I'm trying to find 5, negative 2 pi over 3. So I'm going to count out 1, 2, 3, 4, 5 circles out from the center, getting me out to an R value of 5. And then swing that point around to an angle of negative 2 pi over 3. Try that one more time. Be a little bit more clean. So that's negative 2 pi over 3. So that's got to be my point right here. I'm at an R value of 5 and an angle of negative 2 pi over 3 or 4 pi over 3. Hi.
So that would be different than so which way is like
Gotcha. Yeah, so the question was in another video, I would have said go to 2 pi over 3 and work backwards because of the negative that's there. And it was like, how do you know which way to do it? How do you know which way to solve the problem? I definitely did it different here. So I think unless I did it totally wrong in the other video, I believe what the actual problem was there would have been positive 2 pi over 3 for the angle, but the negative was on the R value instead. So if the negative is on the R value, that's when we work backwards from the angle. So if this were like negative 5, positive 2 pi over 3, then yeah, I would have gone to 2 pi over 3 in the second quadrant, and then worked backward in the fourth quadrant. But yeah, this one had it slightly different, so we do it the other way. That said, all right, we plotted the point. Now we need to convert it into rectangular coordinates. So the x value should be r cosine theta, which is 5 times the cosine of 4 pi over 3. That's negative 1/2. So negative 5 over 2. And y is r sine theta, which is going to be 5 times the sine of 4 pi over 3, which is negative root 3 over 2. So negative 5 root 3 over 2. And the weird little box that I left to write the point in is, honestly, it's a little too busy to write clearly in there, so I'm just not going to do it. Those are our x and y coordinates. Negative 5 over 2, negative 5 root 3 over 2. I guess I should put it as a point at least once. So negative 5 over 2, negative 5 root 3 over 2. That's our point. And in terms of how we would locate that point in space, we'd go 5 over 2 to the left, and then 5 root 3 over 2 down. And there's our point. Hi. So the question was, are those equations, like r cosine theta and r sine theta, are they on the quiz tomorrow? I don't think so. Pretty sure I left them off, but I don't remember. But yeah, if you do need to remember formulas, it is just like there are like 4 of them in total. These 2 right here, and then the Pythagorean theorem and the definition of tangent. Yeah, okay. We are still going along at an okay pace. Number 14. Find the exact value of the following, including a reference triangle, should we need one. So I want to get the cosecant of the tangent inverse of negative 21 over 20. So I'm taking the tangent inverse of some value, which means the answer I get out of tangent inverse is an angle. I'm going to call it alpha. So the thing I really want to get is the cosecant of some angle, yet to be determined. Cosecant of some angle. And I know that the cosecants in terms of ratios of a triangle are going to be the hypotenuse divided by the opposite side. And I already have the adjacent and the opposite side. Or rather, I have the opposite and the adjacent side. So I just need to figure out what the hypotenuse of that corresponding triangle is going to be. So I'll go make a reference triangle. I'm taking the tangent inverse of a negative number. That's going to put me in the fourth quadrant. So I should draw my reference triangle there. There's a triangle. I'll throw the coordinate axes on there, emphasizing that this thing is a reference triangle. The angle alpha that I'm going to get out is this guy right there. Since it is the reference triangle, it'll be on the inside. And label some sides. I have opposite over adjacent, so 21 over 20. Go in for the opposite and the adjacent sides. And then, because I'm in the fourth quadrant, my y values are negative. So I'll put the negative on the 21. And I'll label the hypotenuse C, and I need to solve for it. So I'll go to the Pythagorean theorem. It says c squared is equal to a squared plus b squared. So 20 squared plus 21 squared, which is 400 plus 441, which is 841. And then 841 is the square root of 841 is 29. 841 is 29 squared. Wow, I was aiming with that. So C must be 29. And then I just need to fill out my hypotenuse over opposite from the top. The hypotenuse, there we go. As I just solved for was 29. And my opposite side was negative 21. So negative 29 over 21. We just check some broad strokes real quick. I know I'm taking the cosecant of an angle that's in the fourth quadrant. Cosecant should be negative in the fourth quadrant, so my angle is negative in the end, or my answer came out negative in the end. Passes that quick check. So seems good to me. What else do we have? All right, finding all solutions between 0 and 2 pi to some trigonometric equation. Highlight this between 0 and 2 pi part. Give exact solutions where possible, and 4 decimal places of accuracy where not possible. So let's have to it. Cosecant squared of theta minus 7 cotangent of theta minus 9 is equal to 0. At the moment, I've got too many trig functions in this problem, so I want to get rid of some of them. So I'm going to use a Pythagorean theorem, or a Pythagorean identity, on cosecant squared. I'm going to call that thing 1 plus cotangent squared of theta. minus 7 cotangent theta minus 9 equals 0. And then combine like terms. Cotangent squared minus 7 cotangent theta minus 8 equals 0. 1 minus 9 is -8. And then that thing is factorable. Cotangent theta plus 1 times cotangent theta minus 8 is 0. And then I can separate that out into a couple of equations. Either cotangent theta plus 1 equals 0, or cotangent theta minus 8 is equal to 0. So I'll solve each of those. On the left, I get cotangent theta is equal to -1. Cotangent theta equals -1 is the same as tangent equals to 1 over -1. Either way, if I've got a -1 value for tangent or cotangent, that's happening at the pi over 4s. I want the two where cotangent's negative, so 3 pi over 4 and 7 pi over 4. So I'll just drop those in the box right now. 3 pi over 4 and 7 pi over 4. There's 2 of our 4 solutions. Now I've got to go to the other equation to get my remaining couple. So that means, I forgot a theta. Ms. Griffin would kill me. So that's cotangent theta is equal to 8, or tangent theta is equal to 1 over 8. That's not a value we know off the unit circle. So this is where we'll need a calculator to get the last couple of angles. If tangent of theta is equal to positive 1 over 8, my solutions should show up in quadrants 1 and 3. So I'm going to come up here. I need to find a reference angle, which should be equal to the inverse tangent of 1/8, which is 0.1244. Switching back over to radian mode for this problem. So I'm going to get my answer in radian. Then again, my original equation was that tangent of theta is equal to a positive number. So quadrant 1 will have a solution, and quadrant 3 will have a solution. In quadrant 1, my solution is just equal to the reference angle. So I get 0.1244. That's a solution. Put it in the box. In quadrant 3, my solution is equal to pi plus the reference angle. So add pi to that number, and you should get 3.2659. 3.2659. I'll also add that to the box. And there we have it. 4 solutions, all between 0 and 2 pi. And scroll down to the next one. Find all general solutions for theta. In radian measure, give exact algebraic solutions only. So if I'm asking for exact solutions only, that means we're not going to need a reference angle this time. So everything should be solvable just using the unit circle. So let's go solve for that. This one actually comes pre-factored, which is nice. So I've got either cosine theta equals 0 or sine 5 theta plus 1 is equal to 0. 5 theta plus 1 equals 0. And go collect those numbers. Go collect those values. On the left side, if cosine theta is 0, theta itself must be pi over 2 or 3 pi over 2. And because I want all general solutions, I'm going to add 2k pi to both of those. So in my solution box, pi over 2 plus 2k pi. And 3 pi over 2 plus 2k pi. If you wanted to, you might notice that these things are exactly 1 pi apart. So those two together actually simplify to be just pi over 2 plus k pi. Which actually is a slightly more simplified solution to this one, but I won't ask for all of that. Just getting it into the pi over 2 plus 2k pi or 3 pi over 2 plus 2k pi is going to be good enough. But just in case you happen to notice that, there it is. With the rest of it, I've got sine of 5 theta plus 1 is equal to 0, which means that sine of 5 theta must be equal to -1, which means 5 theta must be equal to 3 pi over 2 plus 2k pi. Anything coterminal to 3 pi over 2 also solves the equation. I then need to make myself some more space. So let's bring this up here. Divide both sides by 5. That means that theta must be 3 pi over 10 plus 2k pi over 5. So then I'll also add that solution to the box. 3 pi over 10 plus 2k pi over 5. Cool. And that's my solution. Hi there.
So you want it, you want it in this format, or you want it in plus 4.5.
Gotcha. So the question was, do I want it in this format right here, the one I've got written down in the box, 3 pi over 10, 2k pi over 5, or do I want it combined into a single fraction, which would then be 3 pi plus 4k pi all over 10. And I won't care either way. Both are totally acceptable. The difference between when I would use one or the other is whether or not I need to keep using this equation. If the equation is my answer, I'll stop in its simplest form, or the first form I got it in, which is this one. If I need to use this equation to find other answers, then I'll get the common denominators because it's easier to work with. But yeah, like I said, I would accept either answer on the exam. Yeah, we better cover this one. Yeah, we definitely won't finish it all today, so I'll need to make a third part to the exam, or to the exam review. So here's some stuff that we know. Given something about angle alpha, something about angle beta, find the exact work of the following couple of expressions, the exact value following couple of expressions. So let's start with alpha. Secant is negative 17/8, and sine is positive. So that's a negative x value and a positive y value. I must be in quadrant 2. So I'll make a reference triangle that is in quadrant 2. I'm sure that'll be fine. Draw my coordinate axes on there. Alpha has got to be that angle. Label my stuff. The hypotenuse is 17. The adjacent side is 8. I'm in the second quadrant, so -8. And then I'll go to the Pythagorean theorem to get my missing side. And it should be 15. 17 squared minus 8 squared will leave us with 225. 289 minus 64 is 225. Square root of that is 15. For angle beta, it just tells me I'm in the third quadrant, in between pi and 3 pi over 2. Don't need to do any more analysis than that. So I will draw a reference angle in the third quadrant. Beta would be this angle. And it's telling me tangent of beta is equal to the square root of 15, which is the same as square root 15/1. So my opposite and adjacent sides should be root 15/1. And I'm in the third quadrant, so both of those should be negative. Both x and y are negative in the third quadrant. And go to the Pythagorean theorem. 1 squared plus root 15 squared. 15 plus 1 is 16. And the square root of 16 is 4. Moving a little fast through this one, but hoping that's okay. So now I need to get sine of alpha plus beta, which should be sine alpha cosine beta plus sine beta cosine alpha. I just color code those real quick. I know I need a value here and here plus another number here times another number there. And I'll need to read each of those from the corresponding triangles. Starting with alpha, sine of alpha is 15/17. Goes in that box. And cosine of alpha is -8/17. Goes in the box over there. Then off of the blue triangle, I need a cosine value, which is -1/4. And then I need a sine value, which is -root 15/4. And then I can combine all that stuff together. This looks like -15 plus 8 root 15 all over 4 times 17, which is 68. And I'm going to hopefully just get to this last part real quick. Cosine of beta over 2. I had an inequality for beta. It was this. Beta is in between pi and 3 pi over 2. I'm going to multiply all that by 1/2 to get that beta over 2 is in between pi over 2 and 3 pi over 4, which puts it squarely in quadrant 2. divide that off real quick. So if I'm going to get the cosine of beta over 2, which should look like plus or minus the square root of 1 plus cosine beta all over 2. I'm in the second quadrant, so I want the negative value. Cosine is negative in the second quadrant. So then I'll solve that out real fast. Negative right there. Square root of 1 plus cosine beta was negative 1 over 4. You had that up above, all over 2. And then I want to get rid of some denominators, so I'm going to multiply top and bottom by 4. This is negative square root of, that'll be 4 minus 1 over 8. Which is negative the square root of 3 over 8. And if I rationalize that thing, it'll end up being negative square root 6 over 4. Ta-da. Cool. All right. And then that's where we'll have to end part 2. So part 3 will be recorded later. I'll post an announcement about it. I'll go live sometime later this week. So if you want to come to see it on Zoom, I'll be there. A couple of last minute announcements. Quiz 8, it's tomorrow. So make sure you go to recitation and take that. There is a survey for like, hey, how did the course go? The surveys are completely anonymous. They're on D2L. So take that anytime between now and shortly after the final exam. There's bonus credit attached to the survey, but because the survey is anonymous, I can't tie it directly to the survey. So I had to create a separate quiz for the bonus question. The bonus quiz, you have to figure out what my favorite number is. If you've been paying attention in class, it shows up on like every exam and worksheet. So you could try to guess what it is. I saw someone tried yesterday, but they didn't get it right. Quick couple of hints. It's not 69 or 420. I guess comes up like every single year. It's not either one of those. In fact, it doesn't include any of those numbers. But yeah, so it's a separate quiz because I have to tie it not to the survey. But I put the answer in the survey. So if you don't figure it out by reading all the old exams, just read one of the questions in the survey. It'll tell you right where to find it. Okay, that's it. Hi. Question? Multiplying the 2 over 2 is just a rational. Got me a square number in the denominator so that I could. Questions in chat. Hey, you are welcome. Trying my best. Yeah, it is at least it is not a single digit number. I'm not giving any more hints than that though. Hi. Oh yes. So the survey itself, you can always go back to the survey and edit your answers anytime you want because it's capable of that. And then the bonus quiz has unlimited time.
Okay. All right.
So yeah, just if you already tried and got it wrong, just try again.
Okay.
Hi.
So over 2, right? How do we get it like over like 7 pi over 8? We put it in as like half value, 7 pi over 6. But
Gotcha.
but for these, you just put it in as what would be the
So in the over 8 example,
yeah.
it's the like 7 pi over 8 would be on the outside, but then 7 pi over 4 is on the inside. So it's the half values on the outside. And then the whole values on the inside. Like 7 pi over 8 is half of 7 pi over 4.
Okay.
All right. So,
You want these hours today?
I do, yeah. All right, great, cool. 3 o'clock. See you there.
Hi, survey email to us or is it on like?
So it's on D2L. There's an okay. Yeah, just click the link. It'll take you there. I have 2 answers.
Can I do exam for Friday? I think the math center is 8 AM to 10, correct? I think you sent me an email about it
Yes.
for a different exam.
Yeah. I have not heard that they'll close Friday morning yet,
Okay.
which means they must still be. It's the last week. They've got to still be. Okay. So yes, that'll work.
Okay, and
I
then
think, I hope.
the final online, is it multiple choice or is there free response, like two type in answers?
Yeah, it
Like the
is.
format, I guess.
Yeah, it is mostly free response, or back up, it's mostly multiple choice.
Okay.
Because we aren't doing the in-person stuff, I've added a couple of free response questions, but less than 20% of the.
So kind of the same format as the online exams.
Exactly.
Okay,
So it shouldn't be a surprise.
okay, got it. Thank you.
For sure, you're welcome. What else we got going on? But do. Hey, if you guys are still here, I hope you have a great rest of your day as well. Also, happy holidays to you too. And yeah, glad you found that at least some of the knowledge I tried to impart actually made it out of my head. I love that for me. Will the quiz tomorrow have material, or we're just going to recitation for the surveys? Yeah, the quiz tomorrow does have material. It's the polar coordinate stuff that I've been highlighting a bit as we went over the practice exam. So it's worksheet 8. And the quiz tomorrow will cover that. Relatively softball questions from that worksheet though. On the reopened web work, the new answers I have do not save or replace my old ones. Is this intentional? Check your number of attempts. Probably what that, I mean, okay. If the answer box has changed to check answer instead of submit answer, that means you've run out of attempts on that problem. And if that's the case, you should email me about that problem and I can add some extra attempts in. And if it's something other than that, I have no idea what's going on. That is the problem. Excellent. I thought that might be it. And then, yeah, the D2L web work grade is out of date. And it will likely stay out of date until after all the web work is due. So I'll do another upload later on. And keep safe. Yeah, man, you too. Hope you have a great rest of your day as well. Oh, I've been recording this whole thing. I love that for me.